Welcome. Today we'll find the exact value of sine of 195 degrees using the half-angle identity. Let's start by writing out our problem. First, let's break down 195 degrees into a sum or difference of angles we're more familiar with. 195 degrees is equivalent to 180 degrees plus 15 degrees. On the unit circle, this means we go around halfway, then add 15 more degrees. Now, 15 degrees is half of 30 degrees, which is an angle we know well. This means we can use the half-angle identity to find sine of 15 degrees, and then use that to find sine of 195 degrees. The half-angle identity for sine states that sine of theta over 2 equals plus or minus the square root of quantity 1 minus cosine of theta, all over 2. Let's write this out for 30 degrees. We know that cosine of 30 degrees equals root 3 over 2. Let's substitute this value. Now, let's simplify under the square root. First, let's get a common denominator of 2, then simplify inside the square root. Finally, we can simplify this to get our exact value for sine of 15 degrees. Since 15 degrees is in the first quadrant, we take the positive value. So sine of 15 degrees equals root 4 minus 2 root 3 over 2. Now, to find sine of 195 degrees, we can use the fact that sine of 180 plus theta equals negative sine of theta. Therefore, sine of 195 degrees equals negative sine of 15 degrees. And there we have it. The exact value of sine of 195 degrees is negative root 4 minus 2 root 3 over 2. This solution shows how we can break down complex angle problems into simpler parts using our knowledge of special angles and trigonometric identities.